All right, let me make sure we're good to go. Somebody let me know if the mic's working here. How's everybody doing? How was your weekend? It's a little windy out there today, isn't it? I'd love if you can, if you're coming back, you were with us last week, and I talked about getting those observation sheets together. Hopefully you're able to do that homework, you're able to complete that. I'd love to see a picture of that, whether it's right here in the comments, take a picture of it. If mom or dad's got to help you with it later on, that's fine too. Just take a picture. You can send it here on the Facebook thread in the comments here. You can send it to my Facebook page. You can send me a private message with it, whatever may be the case. I'd love to see those pictures with all of your observations on what the weather's been doing. But we're going to get going. We had 1 week last week talk about radar and satellite and all these weather tools and weather balloons and observing the weather. And this week we're going to talk more about it, but all leading up to Wednesday when you guys get to put a forecast together. And I think this is a good week for it. The weather is certainly very active out there to get things going for us. All right, I'm just going to load up the comments here on the other page, make sure everything is good to go, make sure everything is working here. Let me know where you're at and how things are, where you're watching us from. First thing, so this is Getting Schooled, and if you're just tuning in, maybe you haven't watched these episodes before, basically we are out there trying to help out the kids in grade school all the way into junior high with some more science-related material. Next week is going to be a really special week because we're going to talk all about some space weather. That's basically types of weather and space, astronomy, a lot of that all kind of combined into one. If you're just watching us, maybe tuning in because you're trying to figure out what's going on with the weather, it is windy. That cold front, we expected to come in about 10 o'clock. It certainly did. And we've got those winds right now gusting to 45 miles per hour, generally out of the west. That's going to continue the rest of the afternoon. Wind advisory is up. So what a day that we have weather-wise. Coming up this week, what we've got in line is today we're talking all about clouds. And this is where we start learning some of those forecasting techniques because, believe it or not, there's lots and lots of different cloud shapes out there, but there's only 10 different types of clouds. And there's only a couple that lead to any precipitation, but a lot of them will kind of point and lead us and tell us what the weather is going to do coming up. So today we're going to talk about all about clouds. Tomorrow we're going to talk about fronts, low pressure, high pressure, which, by the way, right now, if you're wondering why it is so windy outside, we are stuck between a very strong area of low pressure and a very strong area of high pressure off towards our west. We're caught right in the middle. That is the wind machine. That is Mother Nature's wind machine. If mom or dad were to run over a nail or something with their tire, and that air obviously would rush out of the tire, but you were to put your finger over that hole, you would feel the air coming out of it. Well, that air is rushing towards the lower pressure. There's lower pressure outside the tire, higher pressure in it. And once everything's balanced out, the tire goes flat and there's no more air moving. That's not a good thing for your tire. But in this situation, basically, we have a really large tire in the atmosphere that is trying to go flat, and we're getting all the wind coming out of that, basically. So that's what's happening. All that air is rushing towards the lower pressure, and we get a lot of wind. But today, it's all about clouds. Tomorrow, about fronts and pressure. Wednesday, we are going to forecast. You guys are going to put your own forecast together, and I'm going to give you the tools. I'm going to help you out. I'm going to show you what we do here. But late this week could be interesting weather-wise, and so you guys are going to have a fun forecast to put together on Wednesday. I'm excited for it. Next week, space weather. We'll talk about the northern lights. We'll talk about meteors, eclipses. It's going to be a fun week, too. So let's get right to it. We'll start off with clouds coming up for today. So I'm going to take you over to the other screen right now, and we'll walk through it. So there are 10 different types of clouds, and right now, what we're looking out at outside is we've got the clouds that are moving by really, really quick in the atmosphere because the winds are moving really, really quick. But that's the big thing. So this might look a little complicated, but it's okay. So this is a big screen here full of clouds, and I'm going to start off high in the sky. So you've got basically these high clouds here that are made up of ice because it's so cold up there. That anything that's this high in the sky, even if it's 95 degrees in the middle of the summer, you go that high in the sky, and that's all ice clouds. Cirrocumulus over here, cirrostratus. I don't know if I even see that cloud up on this particular one, but we'll get to it coming up on the next one. You move down a little bit farther, and you get these alto clouds. I know alto doesn't always mean mid-level, depending on if we're talking about music or something else, but it does in this case, we're talking about mid-level clouds. This is altocumulus, altostratus, and then you get lower to the ground. And right now we have some lower clouds. For a lot of us, we have these stratocumulus clouds. There's stratus, there's cumulus, and guess what? All of those are not producing rainfall. There's only two that will produce a bunch of rainfall, and one is this really tall cloud. It goes all the way up into the sky. This thing can go up miles and miles into the sky. That's our thunderstorm cloud called the Cumulonimbus. And there's Nimbostratus that'll give us some clouds too. So I'm going to take you to the next graphic, and I think it does a little better job kind of showing the overview. The National Weather Service has put this guide out, and I really like it. So again, we'll start off high because I'm going to start off where the airplane is at. We all know the airplanes are high. This is an airplane on our graphic, and it's flying through those high wispy clouds, and it's looking down on a lot of other clouds here that we've got. But when it flies in, we get cirrus clouds, very serious looking clouds. Actually, they're not. Actually, what it looks like is this cotton candy that is kind of like pulled apart, really, really thin, or really wispy clouds high in the sky. We have cirrostratus and cirrocumulus, but these are all of those ice clouds. And then we work our way down a little bit, and we've got nimbostratus, and this is basically a steady rain, a steady snow. So that one can produce precipitation. Our thunderstorm clouds over here on the side, it goes way up in the sky like I mentioned before. But then we've got some other low clouds too. So let's go ahead, let's dive right into this. I'm going to show you what they mean and why they're important. Some of them are pretty, some of them are not, but they all kind of tell us what the weather is going to do. So if we were to take a look at this picture right here, these are high clouds. We're going to start off high, we're going to go low. These are cirrus clouds. And what they mean is that we have fair weather basically coming in. So we've got a blue sky. Here, this is our cotton candy cloud, right? And these wispy little clouds kind of stretched all the way through the sky, kind of see through it. But that means good weather. We usually don't have any bad weather at all when we have these types of clouds around the area. So it looks really good. All right, so these are the cirrus clouds. Kind of in the same category, we have these cirrocumulus clouds. And these, out of all the 10 cloud types that we have, this is the rarest cloud out of all 10 of them. So they're high icy clouds, but they're really, really tiny little cumulus dots kind of all over the place in there. And that can let us know that we might start to have enough instability in the atmosphere that we might have rain, say a day and a half into the future. So they could let us know that we have rain coming in 12 to 36 hours away. That could be a sign. But again, this is a pretty rare cloud. And most of the time, before we get rain, we're not going to see this at all. I'll tell you what, though, you get these clouds when the sun is going up or sun's going down, I don't think you can have a more beautiful sunrise or sunset. They produce some spectacular colors. So if you want to think of anything with these clouds, they are rare and they produce beautiful sunrises and sunsets that are called cirrocumulus clouds. So still have the cirrus, basically part of it, but they've got little cotton ball cumulus clouds that are in there. All right, let's work our way down. And the next one is cirrostratus. And so they block out a little bit more of the sunlight, and they usually do tell us that we've got rain coming. Not yet. Usually we're probably 24 hours or 36 hours away is usually where we're at with these. Whoop, we jumped ahead here. So let's go back. So yeah, there we go. So usually about a day and a half away, we start to get some rain. We start to see this. So if you see the sun, it's showing kind of a halo through the sky. It's a pretty good indication that's what we've got. All right, so now we're going to work our way down, and this is usually what happens. When we have rain or steady snow come in, usually it starts off with those cirrus clouds, and there's nothing really going on, and then you start to get the cirrostratus, and then these high clouds start working their way lower and lower down to the ground. So now we're in the middle level clouds. These are altocumulus. So the only thing different between the cirro and the alto is basically where it's at elevation-wise. And you can see these little clouds, they're closer to the ground, and so these little cumulus clouds are starting to get a little bit bigger that are in the sky. And that's how we know that it's kind of in the mid-levels. But that usually lets us know we're within 1 day of rainfall. Usually more than 6 hours. Probably if you saw them today, you'd probably expect rain like tonight or early tomorrow morning, that type of thing. All right, so now let's take you to the next cloud. We'll just kind of keep working our way down. In the same category, we have altostratus. And you know what? Yesterday, I was on a walk with my kids, and I looked up in the sky, and I said, what are these clouds? They said stratus, so they got part of it right. It's altostratus, and that's key because usually we see these and we know we have rain on the way. So I said 6 to 24 hours here. It's generally probably about 12 hours away. I'd say 6 to 18 hours most of the time. And you barely see the sun shining through, and then it's just kind of stratus across the rest of the sky. That's a really good indication we've got rain or snow on the way, and it certainly worked out. So we had it yesterday during the afternoon, and sure enough, we had rain overnight. So it worked out really well. That was a good indicator to tell us that we had some rain on the way. Now this is a big rain cloud. It's just dark, it's gloomy. It's called Nimbostratus, and when we have it, we don't have to worry about when it's going to rain because it already is almost all the time, either rain or snow. So it's a stratus cloud. Stratus means there's really no shape to it, but nimbo meaning rain or precipitation. And so that's what we've got. And so when that cloud's around, it's already raining, so we don't really have to figure out what it's going to do. Low clouds, stratocumulus, and I'd have to look outside right now, but it looks like that's still what we've got. Quite a bit of those stratocumulus is back up there. Usually precipitation's unlikely, and that's kind of where the boat that we're in right now. Sometimes we can get a little bit of drizzle with it, but it doesn't. Even though it's kind of an ugly look outside. Sometimes these clouds can be ugly, but they don't necessarily mean that we're going to have rain or anything like that. Speaking of ugly. This is about as ugly as it gets. These stratus clouds all together, also fog, same thing. Sometimes the stratus clouds on the ground, it's fog. If it's not, it's above the ground, but it still looks kind of nasty. But other than mist and drizzle, that's the only thing it produces. Nothing, no rain, no snow, usually just a little bit of mist or drizzle. And then we go into the cumulus clouds, and there's 3 types here that we can have, essentially. These are just puffy little fair weather cumulus clouds. So fair weather, that means nice weather, no problems, usually nice and sunny when we have these. And we get this in the summertime all the time, almost every single day we end up having these fair weather cumulus clouds. Not every day, but just about every day it seems like. And then the next category of clouds that we've got are when these clouds decide not to be so fair weather, and they start to build and build and build in the sky. When you see this, not only are you going to have rain, you're looking at thunderstorms between 1 and 6 hours away. When these clouds start to go up in the sky like this and start building, they're not into big thunderstorm clouds yet, but they're going to get there. They're growing into these big towering cumulus clouds. So cumulus, if they're really tiny and they're not moving up into the sky, those are fair weather. That means the weather's going to be nice. You start seeing the clouds build up like this, you can tell all of your friends, you know what the weather's going to do. Between 1 and 6 hours, usually it's like between 1 and 3 or 4 hours, honestly, you're going to have showers and you're going to have thunderstorms. This happens in the late spring and also in the summer quite often. When we get the storms, this is what happens first. So it's a good indication of what's coming our direction. The other one is the last cloud I think that we've got on here. Here it is, the big king of all the clouds. It is the thunderstorm cloud. This one's not towering anymore. It's gone all the way to the top of the lower part of the atmosphere, and it basically hits a lid on the atmosphere, and then it starts to spread out and it just takes over the sky. Look at that. It is a big, monstrous cloud. And this is where all the thunderstorms, every tornado that develops is coming from these clouds if they become severe enough. Sometimes this updraft becomes so strong, it punches a hole right out of the top of the lower part of the atmosphere, and you get this anvil cap on it. That's when you know you got a really powerful storm. If you ever see that, you got a little cap on top of the storm. That's a strong one. It almost kind of looks like an umbrella, doesn't it? Well, you need an umbrella because when these storms come down, they give you all kinds of rain. They just kind of fills the sky up. So those are our big storm clouds that we're looking at, or all the clouds for that matter, that we've got. So I'm going to walk back over here and probably get to questions and all of that because we just ran through all the clouds. We've worked our way from top all the way down to the bottom. And sometimes the clouds are pretty, sometimes they're ugly, sometimes it means we got rain and snow and storms on the way, but there are times where you can look at those clouds just like yesterday. Yesterday was a very good clue. You could have not looked at any of your observations or any of the really neat weather equipment that we've got to forecast the weather. And all you have to do is look up at the sky and say, I know what's going to happen later tonight into tomorrow morning. There's a good chance for rain. And sure enough, it worked out like a charm just by looking at those clouds and then seeing what ended up happening later on. We ended up getting those showers. So we'll get right to the questions. Again, tomorrow, we're going to talk about fronts, and we're going to talk about low pressure and high pressure and why that is so important. I'm going to show you how to look at weather maps and kind of get an idea of how to forecast the weather from that. So today we talked a little bit about clouds, and if there are clouds that you want to go back and look at this video later, go back and look at the video later. If you forget it, or if you need to write some of this stuff down, go ahead and do that. Also, just another reminder, if you haven't already, I want to see your observation sheets. I want to see all the hard work that you've done over the weekend on observing the weather, whether you've filled out a bunch of information or just a little bit. Let's see, we've got some questions coming in. What kind of a layered and tornado-like spiral clouds were here on Saturday? Let's see, Saturday. Let's see, we had kind of layered and tornado-like spiral clouds were here on Saturday. Now I'm trying to remember what cloud it was that you may be looking at. I will say too, when it comes to different thunderstorm clouds, so I went through the 10 basic clouds that we've got, and you can have all kinds of shapes and all kinds of things that kind of come from that, and there's a lot of other cloud types that is formations that clouds can form that is not its own cloud by itself. I'll give you an example. I'll give you a couple examples. One, we talk about during severe weather a lot. We talk about a wall cloud. We talk about a shelf cloud. Those are features that are part of that cumulonimbus, that thunderstorm cloud. So it's not a separate cloud by itself, but it's all a part of that thunderstorm cloud, and that does produce a lot. Going back to late last week, we got a lot of cloud pictures in from, how many of you guys, Thursday going into Thursday evening in particular, we had big showers full of what looked like, in some cases, snow. It also kind of looked like ice. It was actually, the word for it was grapple. It was basically soft hail that was coming down. But when those clouds got away, you could see what was like miniature thunderstorm clouds towering into the sky. That's exactly what they were. For most of us, we didn't have the lightning, but it was the same cloud. It was a cumulonimbus cloud going up. In that case, it wasn't producing rain. It was actually producing snow and soft hail, but it was the same processes there that was creating all that. So it was pretty neat stuff. So I'm trying to think back. If you happen to take a picture of those clouds on Saturday, send it to me and I'll try to get that answered. But I'm not sure which location and what cloud type specifically that we're referring to from those clouds there on Saturday. Let me pull up some more questions. If anybody has any other questions, again, it doesn't just have to be on clouds. It can be on severe weather. It can be on today's wind, why it's so windy, anything related to that, or forecasting. We can get to that as well. So let me pull up the latest over here. Okay, what cloud does a tornado grow in? The tornadoes grow in that cumulonimbus cloud. And I'll tell you what, just about there are several clouds that can look scary, but there's only one cloud that actually gives you scary weather, and that is the cumulonimbus cloud, the big king cloud that I talked about, the thunderstorm cloud. I'll pull it back up to give you another idea of what we're talking about with that. But it looks like a beautiful photo here, the one I'm going to pull up, but it's certainly got that big thunderstorm cloud going straight up into the sky, the winds are going straight up, and then it spreads out quite a bit. So that's the storm that produces hail. That's the storm that produces the damaging winds inside of a thunderstorm, the tornadoes, the shelf cloud, the wall cloud, the green sky. All of that comes from that cumulonimbus cloud. And that one isn't a low cloud, a medium height cloud, or a high cloud. It's all of the above. It actually goes from the ground. And depending on how warm it is, depending on basically how far up in the atmosphere it can go before it hits its lid, before it can't go any farther, that might go up a couple miles. It might go up as much as my goodness, 5-6 miles easy, depending on where you're at around the globe, how warm it is, that type of thing. Summertime, these clouds can grow much higher into the sky after it becomes very hot and humid. Let's see. We've got, I think it's Colin here. Why do cumulus clouds stretch up? Great question. So the cumulus clouds, they stretch up into the sky because there's, let's see, if you think of any, whether it's hot air, it's going to rise. Same thing like if you're going to fill up maybe a bucket of water or maybe a bathtub full of water. If that water is too cold, and now all of a sudden, oh no, it's too cold, I want it to be warmer, you throw in some hot water into it, that hot water, it likes to rise. Eventually, it's all going to mix together and it'll become like warm water, right? But that cold water, and same thing with air, the cold is more of a dense atmospheric setup. So whether it's water, it's cold water, or whether it's cold air, it likes to just kind of, it's heavier and it likes to kind of sit down a little bit lower. Warm air is, typically it is less dense and it wants to rise, it wants to go up, and that's where it wants to go. So if on a really hot day, and this is why we get them all the time in the summertime, really hot day, sun's beaming in, temperature at the ground might be 90 degrees. Well, the air above it is colder. If you've ever gone up a mountaintop, you know that it gets colder. The farther up you go, the colder it gets. So down next to the ground, it's its hottest. You go higher and higher up, it gets colder and colder. Well, that hot air begins to rise, and as it does, that hot and humid air begins to condense as it gets colder, and so that cloud develops, and that hot pocket air just keeps going up and up and up until something stops it. So on a day where there's fair weather cumulus clouds, about a mile above the ground, there's enough warm air to kind of put a lid on it, and those clouds never grow tall enough to turn into big thunderstorm clouds. On days where we get the thunderstorm clouds, there's no lid there. The lid's way up into the sky, maybe 6, 7, 8 miles up into the sky. Because of that, these clouds can grow and grow and grow and get bigger and bigger and bigger. And so that's why it likes to go up and you get that hot air to rise here early on. What clouds indicate danger? That's the Cumulonimbus cloud, so the one that we've got up again. That's the one that indicates, I guess you could say, real danger. There's a lot of clouds that look scary. The stratus cloud's a low gray cloud, and it's an ugly looking cloud. It just kind of hangs there, but the only thing it's going to do is maybe give you some mist or fog. That's it. Stratocumulus clouds. So if we look outside right now, it kind of looks ugly, right? It doesn't look all that pretty. There's these kind of layered clouds that are moving across the sky pretty quickly. The only thing they're going to give us is probably a sprinkle or two. That's about it usually. Let's see, Nimbostratus, it's another really dark cloud. It gives us steady rain or steady snow, but outside of that, nothing severe. So it really is that Cumulonimbus cloud. It's only one cloud out of all 10 that take place, but that gives us all the rough weather that we have. Let's see here. Okay, so good question here. How can there be clouds in winter when it is too cold for water to stay as a vapor? Well, what happens is that water, there's a couple things that are going on here. One, this is a really good question, and it's tough to explain here for everybody. So I'm going to do it in two different ways. One, you can have clouds made out of ice, and that happens all the time. So you've got those high clouds that I was showing you, the cirrus, the cirrostratus, the cirrocumulus. Those are all high clouds made out of ice particles that are just kind of, the cirrus clouds are real wispy, kind of looks like pulled cotton candy. Now, the other thing is that we could have clouds that have water vapor in them and lots of water vapor in it, but yet it's below freezing. And this is where it gets a little complicated, because for every particle of snow and ice that is out there that falls to the ground, there has to be something that we called an ice nuclei. There has to be a little tiny piece of dust or something. And if there's only one thing you learned today, this might be it. Every raindrop, every snowflake, everything that falls to the ground has some microscopic piece of dust or something in it. So think about that. Every time that mom or dad or anybody says don't catch snowflakes on your tongue, or don't eat that snow, or it might be dirty snow. Actually, whether it's dirty snow or not, there are little tiny particles of dust or something like that. That's where the raindrop or the snowflake begins, because that little particle is where that water vapor begins to collect on and it forms it. So they've done some studies where they found that where there's a lot of air pollution, there can actually be to the east of that area where the wind pushes that air pollution. Sometimes there's actually more rain in that spot than what there is all the way around it, because there's more dust particles available for more of those water droplets to form on it. So same thing for the problem when it comes to ice and water is that the ice nuclei and the water little dust particles are not the same. Water can basically form on just about anything. Ice has to be very specific kinds. And so because of that, you get clouds made out of both ice crystals and supercooled water droplets. And supercooled water droplets are a really cool thing because they're water droplets that are pure, completely purified, that can survive without freezing and temperatures as low as 40 below zero, potentially. That's a big deal, and that's part of the reason we get hail and we get all these other things that happen in the atmosphere, because you have water droplets and ice particles in the same cloud at the same time, hitting each other, moving all around. That helps create lightning, that helps create hail. So that's a really good question. It's a complicated way to answering it, but that's the basis back behind it. So again, I think I've lost who asked that question, but very, very, very good question. Let's see what we got. How does a cloud fill with water? Okay, so is that hot air, warm air is just rising and going up. It is going to cool eventually, and as it cools, it's going to get to a point to where it's going to cool enough where there's enough moisture in that cloud to where it's going to form a cloud. And as it continues to go up, it continues to build moisture, eventually that cloud's going to have so much moisture where it's going to be so heavy, eventually gives way to more water droplets and rain, and goes from there. So that's how it basically fills up. It all has to, you have to get the air to rise. There has to be enough humidity in the air. It has to go up. And tomorrow we're going to talk about fronts, and we're going to talk about pressure systems. And those are really important because when you have a warm front, a cold front, or an area of low pressure, the air wants to rise. Sometimes if you live in the mountains, the air is going to rise anyways, because as the winds is coming into the mountains, it hits the mountains and then it forces it up. And that's why mountains get a lot more rain and snow than other places, because it forces those clouds to develop, and a lot of times it forces rain or snow out of them, and sometimes lots and lots of snow up in the mountains. That's why they get so much. So you have to have the air to go up. That's kind of the secret ingredient to be able to getting these clouds to form anyways. If the air is always going down or it's never moving, then you don't get the clouds essentially to begin with. It's much tougher to do so, we'll put it that way. All right, Brady asking, can you actually get struck by lightning while under a tree? You can, and a lot of times the problem if you're under a tree is that, let's say you're under a tree but you're not even touching the tree, the lightning comes down, hits the tree, the lightning may not hit you directly, but then it goes all the way down into the roots, and then that electricity spreads out. And I've seen photographs, amazing photographs, of how the lightning, it's blown a tree up, but then the lightning is crawled in the root system out 10, 15, 20 feet away from that tree. It kind of follows the roots out. And so that becomes a big problem. Not to mention, you don't want to be under a tree if the tree gets hit by lightning and you don't even get hit, because it's going to blow the tree up in many cases. So that's kind of a bad deal. So yeah, lightning generally likes to go to the tallest object. So the good news about a tree is that the tree is usually taller than you. The bad news is that you're close enough to the tree to where you're essentially going to get struck too. And that's why we say you don't want to go under a tree or near a tree during a lightning storm. All right. What's the cloud that can go the farthest up in the summer? The cloud that's the tallest, that goes the farthest up in the summer, is a cumulonimbus. So it goes, just the thunderstorm cloud again that I've got up here. So the base of that cloud can be maybe 500 feet to 2,000 feet off the ground, which may seem like a lot, but that's not really that far up. But it can stretch all the way up to 30,000, 50,000, 60,000 feet, depending on the type of environment that we're in. With that said, cirrus clouds, cirrostratus and cirrocumulus clouds, those are those high ice clouds. They're way up there too. They're up there at 30,000, 40,000, 50,000 feet, but they don't stretch all the way down to the surface. All right, what about during a storm, you look up and see two layers of clouds moving in different directions? Okay, very good question. So in this case, what you're looking at that point is you're looking at two different cloud layers. So I just gave you very simple diagrams of the high clouds, the mid-level clouds, the low-level clouds. Well, it is very possible, and it actually happens rather often, to where we have multiple layers of clouds happening at the same time. So today we look at the clouds outside, we've got some stratocumulus clouds. Unless I've got satellite or something else to help me out, I have no clue if there's clouds above that or not. I can only see this. But if we get into a situation where, say, half of those clouds are there and they're moving, I can look up and see if there's any more clouds above it. And if you start looking sometimes, yeah, especially when we have thunderstorms, there are clouds moving in different directions at the same time. Really pretty cool to see. It also lets us know that we have wind shear. That's exactly what wind shear is. The wind's moving in different directions at the same time. And depending on the direction of those winds and the speeds of those winds, it could mean that we have severe weather potential or even a chance of a tornado. It doesn't always mean that, but sometimes it does. So that's certainly a good question there. Can lightning strike the same place twice? You bet, and it happens a lot more than you think. That's another weather myth. People think, oh, lightning can't hit the same spot twice. Absolutely does. In fact, the taller objects get hit quite a bit. Our tower is the tallest object around it out in Oregon. I have to ask our engineers again, but I think it's about 900 feet. I know it's somewhere between about 840 and like 920 feet. That's really tall up. And if you're out there, you know it's flat all the way around it. It is a lightning magnet out there. We had thunder snow. That's another cool thing that we'll talk about another time. But that is the ingredients of a thunderstorm and snow combining at the same time, which means it's a thunderstorm with lightning, but instead of rain, you have snow falling. One of the coolest weather things ever. But anyways, we had thunder snow out in Oregon, and we had one lightning strike, and it hit our tower. It didn't hit anything else, but it hit our tower. The reason it got hit, well, it's so tall up. In fact, the Statue of Liberty gets hit, but the Empire State Building, I think, gets hit like 28 times a year or something like that. So absolutely, those tall objects get hit a lot. In fact, engineers know that, and they design those buildings to basically take on the lightning and to get rid of the charge safely in those cases. So they're aware of that, especially when you get those really tall buildings. Does a snowstorm and a thunderstorm both come from the cumulonimbus cloud? Good question. Sometimes it does, sometimes it does not. The other day on Thursday, when we had the snow and the grapple, the little ice pellets flying out of these clouds really at a really fast pace before it melted, that was from the cumulonimbus cloud. That was a thunderstorm cloud. Thunder snow that happens, that's from a thunderstorm cloud. Makes sense. It's a thunderstorm. It's just snowing at the same time. Yet, our big snowstorms that we get, generally, not always, but generally, they are coming from Nimbostratus clouds. And that is that steady rain or steady snowmaker that usually lasts for several hours at a time. And by the way, that is the cloud and the weather that is very predictable by looking at the clouds. That's more predictable than, unless you look at a cumulus cloud and you just start seeing it towering up into the sky, you know a thunderstorm is very likely from that in the next couple of hours. But if in the wintertime, these snowstorms that do happen, a lot of times you can see it kind of developing. Maybe 2 days away, you just have cirrus clouds. And then 36 hours away, it's cirrostratus. And then some alto cumulus mix in, and then it's alto stratus, and next thing you know, it's nimbostratus, and it's snowing pretty good. So you can usually see those cloud layers start to lower down to the ground and get thicker and thicker before the rain or the snow begins. All right, looks like we've gone through all the questions here. Again, if you haven't already, send in those observation sheets, take a picture of them, send them in as a comments, have mom or dad send it to me in a message. I'd love to see them, see what you guys have been up to. And then tomorrow we're going to talk all about fronts, and we're going to talk about low pressure. We're going to talk about why they're so important. And again, I kind of gave you a hint. It helps get the air to go up. And if you can get the air to go up in the sky, that's when you start to get the clouds and some interesting weather to develop. And then Wednesday, it's all about forecasting. It's all going to be you guys. I'm going to help you through it, but it should be a lot of fun. All right, take care.